Hey everybody, this is Mr. Hetria again, here to go over another chemistry learning target with you all. So for this video we are doing learning target 2.1. I can draw particle pictures that show the relationship between temperature and motion of particles. So if you would like to, I would recommend watching a video. If you go on YouTube, look up Eureka Solid, Liquid, and Gas, because it gives a nice summary of the states of matter, and we're going to be talking about that in as we talk about whooshies. So I'm going to show you some clips of the video in this presentation. All right, so solids. The particles in solids are considered to be in a lattice work structure, which means that they're all right next to each other. They're vibrating just a little bit. They're not touching each other, but they're in a very organized manner. They're arranged in a very organized manner. So according to the video, it said that particles do the dance, and I'm going to show you exactly what they mean by that. All right, so this is what I mean by the particles in solids do the dance. They're just kind of moving toward each other and then away from each other, never quite touching each other. All right, so if you look at the right part of the screen, this is actually why we are going to draw particle pictures of solid substances actually in a different way. You're just going to draw the particles touching each other just like you did in the previous unit, but you're going to add like zigzag lines to show that they're vibrating, okay, to show that they're doing that dance. Okay, so if you look at the left part of the screen, I put a sun there and I put an X through it. So without sun, if you have a piece of chocolate that is shaped like a rabbit, you put it outside and there's no sun, that piece of chocolate stays solid and it continues to look like a rabbit. Again, the particles in the solid, they're very organized. So the particles in that solid rabbit are very organized. They're doing the dance in that lattice structure. Now, if we add sun, and this is what I am showing you here on the right side of this slide, if I add sun to it, what happens to the rabbit? The rabbit starts to melt. So the chocolate rabbit starts to melt and it starts to lose its shape. So if you look over here on the right, you see these two, the particles are a little blurry because they're moving a lot quicker than they were in the solid. And I'm going to go ahead and show you a clip of the video right now to show you better represent that. So as you could tell, as the sun starts to hit the particles, they actually start moving quicker. And now they're kind of blurry because they're moving quicker than they were before. So the hotter they get, the faster they go. So they eventually just slide all over the place. They're not organized anymore like they were in solids. Eventually they're sliding all over the place like a free-for-all. All right, so this is it's going to show you what happens to the solid rabbit here as the sun warms it up. Particles are moving a lot quicker. So now look what happens to the shape of it. It starts to lose its shape. It starts to melt until it turns into just a chocolate puddle because the particles are moving so quick. They're not organized in that lattice structure anymore. Okay, now that we've talked about what happens to particles when they heat up, I'm going to introduce you to our upcoming concept called a whooshy. It's going to be a fun concept to learn about. First off, before I tell you what it is, um, think to yourself, what does whoosh mean to you? When you hear the word whoosh or whoosh, what does that mean to you? Pause the video, think about it. All right, so if you've ever seen comic books or read comic books or seen cartoons, you may have seen the word whoosh represented when things are moving quickly, or yeah, pretty much when things or when characters are moving quickly. So I should put some images over here just to kind of give you a heads up of why we're using whoosh to represent um, the movement of particles. All right, so we know that whoosh means movement, and what we're going to start to do is use something called whooshies to show movement of particles. Take a look at the left side of your screen with the particle pictures of the liquid that are, so the particles have a kind of like a tail behind them. I highlighted them in blue. On the left side, you have particles with one whooshy, and we're going to call that tail a whooshy. On the right side, you have particles with two whooshies. You're going to call, yeah, those tails whooshies. So the particles that have two whooshies, those are hotter than the ones that have only one whooshy. They are moving faster, so that's why we give them more whooshies. Same thing on the bottom. The bottom I highlighted the whooshies with purple, but instead of a liquid, we are showing it in the form of a gas. All right, just to review, solids, we do not draw any whooshies. We never draw whooshies in solids. To show that they're moving, that they're vibrating, we're going to draw the zigzag lines. In a cool liquid, you're going to put less whooshies than in a warmer liquid, and the same thing for a gas. In a cool gas, you're going to put less whooshies than in a warmer gas. All right, so I'm going to give you a summary of our rules for particle pictures and drawing whooshies. So please pause this video, read through the whole slide, and then resume it to hear my overview of all of this. Um, all right, so our rules for particle pictures, we are not showing whooshies in solids. Solids have particles that are vibrating, so we're just going to use those zigzag lines like I showed you previously. In liquids and gases, more whooshies uh, represents more movement or faster movement of the particles. Less whooshies represents less movement or slower movement of the particles. Whooshies on each particle. The lines should be parallel to each other. They should also, on each particle, those lines should be going in the same direction, and they should be right next to each other, just as you see over here, the ones that are highlighted in purple and the ones that are highlighted in blue. Last point, whooshies on the same particles should be in the same direction, but whooshies on different particles in the same particle picture should be in different directions. This is to show that the particles are moving in all different directions. So if you look at the particle picture over here, highlighted in purple, you see the whooshies are of the particles are all going in different directions. Same thing with the particle pictures highlighted in blue. Everybody, thank you so much for your attention. I really appreciate you watching this video. I hope it helped you out. If you have any questions, please don't hesitate to ask your teachers. Thank you guys and have fun. P.S. I just said thank you guys. I meant to say thank you all. Thank you for watching this.